I think that we can start. I hope that we are online. Andrea, maybe can make me sure that we are. Okay. Welcome, everybody. It's a new experience, an old and new experience to be in person here in a classroom with you. And this is the open house of a master degree in data science. And my name is Marco Ferrante, and I'm the head of the coordinator, the president of this, the boss of this master degree. Okay, this is a small blah blah, and big data is one of the key terms of our contemporary world, and this to justify why people decided to construct a master degree in data science and offer this to the students. Existence of nearly limitless amounts of data that have to be collected, managed, analyzed, and processed by competent professionals bring out the need to a new figure, and this new figure is that of a data scientist. Okay, we have this part. Okay. What is a successful data scientist today? He needs to receive a multidisciplinary learning path, which combines technical skills coming from engineering, computer science, statistics, and mathematics, with knowledge of different sectors in which data processing is required. Has to be able to process the data and translate it into information useful for cognitive and decision-making process. Okay, these are nice words. This is what we need. This interdisciplinarity, engineering, computer science, mathematics, and statistics. This is what is usually not easy to do because every master degree is in one specific department that is focused or in mathematics or in statistics or engineering. What we have done in 2016 here at the University of Padua is constructed this master degree, really putting together 5 different departments and one foundation, the Bruno Kessler Foundation in Trento. And as you can see, involved in the project are really the 5 needed departments for this project. The Department of Mathematics, where we are now, the Department of Statistics, of Information Engineering, where there are all the information engineers, Department of General Psychology, and Department of Biomedical Sciences. These are to, in some sense, to demonstrate that there is really an interdisciplinarity, and people that teach any of the field, applied field or fundamental topics, are experts of these topics. And this is written here. The master degree in data science is highly interdisciplinary and is fully taught in English by international established researchers. And the other things that I want to stress out is something that I always say, why this master degree is really a new degree. One empirical proof of this is that nobody of your instructor, the professor that we will encounter in your studies, if you will decide to study, to enroll in our master degree, is graduated in this master degree. Because nobody of us comes from a data science master degree, because this is pretty new. There are mathematicians, statisticians, engineers, but people from computer science, but nobody else. And this is something that don't happens very often. The offer usually is with a master degree with a name that is the same name since 30, 40 years. Okay, quickly. The program has been built to, highly acquired this figure of data science is by industries, consulting companies, and public institutions. And there is a big possibility to continue with a PhD. And so this means in academia too. And our graduated will be able to master tools coming from engineering, computer science, statistics, and mathematics. We have already seen this is our idea, our scope. Okay, 2 years ago, before all the COVID, we started in 2019, that academic year, 1920. We made a big change in our master degree, and we organized this in 4 curricula. 4 curricula means that we focus the studies in these 4 curricula: machine learning, mathematics, biological data, and cognitive and social data. I go very quickly here because then Professor Rinaldi will explain more while this curricula. We decided to differentiate the offer for many reasons, because it's a better organization of our master degree, and because of the numbers that here it is the last line, but I just comment to you that in the first year we had a total number of 19 students enrolled in our master degree. The second year they arrived at 39, the fourth year 2 years ago at 60, and last year we had more than 100 students, and we forecasted to have more than 120, 130 students. And the second thing that you can see, this is completely with a PDF, it's no more very easy to read this table. The Italian students is the first column, and these are the international students, and this number is 64. Up to 9 this year, for the next year, the 21-22, we have already 64 international students that apply and pay for to be here in the next academic year. And to give the idea that the international of this master degree, this is the proportion of the origin of our international students. We have a big part of students that come from Asia. This means from Iran, most of all, some students from China, few students from Pakistan, and there is a big amount of students coming from Europe. We have a lot of students coming from Turkey, and the students from Germany, Russia, and many other countries in Europe. But we have also students from Africa and students from America. We have from North America, South America, Canada this year, Mexico, Brazil, and so on. So the environment is really international. Already this year was so, but the next year we forecast that it will be even more international. This is very important because even if my English is sufficient and nothing more, or some of my colleagues is much better, the environment is really international. You will have classmates that are not Italians, are international. Most of these are English mother language. Others speak English as a French language like you, but I think that is really a rich environment where to spend, I hope, just the next 2 years and no more than 2 years. And to finish this, having the possibility to dress this nice t-shirt that is now allowed just for professors. And when you graduate in this, we make a gift to you with these t-shirts. It's very expensive because it costs 2 years of your life, but I think that it's important for you to have at least. Okay, this is a joke, stupid joke, but you understand that. We are very proud of our master degree, and I think that is a good. It was something that it was not so clear at the beginning that can be so successful, but working hard in this, and I hope that the student that we ask to make a speech later will confirm is something that can be really, really a good choice. Now I let Francesco to be more precise and complete.
Thank you, Marco, for the nice introduction. If you don't mind, I will close this up. Have a better look at the slides. Okay, so yeah, sorry, bad habit. So as Marco said, I'm Francesco Rinaldi, one of the professors here in the data science program. Today I will quickly give an overview of the existing curricula here in the data science program. And I will give you some details related to the study plan, how you can fill in your study plan. And of course, I will give you some basic info related to the Erasmus Plus program, which is also another important point in our data science program. Okay? So I will try to go very quickly on this side because Mark already said plenty of stuff, so I don't want to waste your time. But what I want to highlight is that there is plenty of data science model and methods around available, and it's really these models and methods that make things work. So a data scientist right now needs to understand and hopefully develop some tailored models and methods for dealing with data. So this is our main goal in here. So keep in mind, understanding and developing, hopefully, models and methods for dealing with data. Okay? So a few words about our data science program. It is very successful, as Marco said, program that enables you guys to build and analyze structured models for the representation of concrete applications. Of course, you will be also able to probably choose and develop, as I said before, methods for handling those models. You will also get a deeper understanding of tailored techniques for data analysis. And of course, you will try somehow to combine and develop all these tools in order to solve complex problems in the end. Because our main problem, keep in mind this, we want to solve complex problems, okay? And data science is, this is all about, okay? Solving complex problems. So managing those tools in a proper way is the key for your success. The data science course, all our courses actually put a big emphasis on notion coming from statistics, optimization, machine learning, theory of big data representation, and of course some specific fields related to the chosen curriculum. Okay? And here are our 4 curricula we have right now. We have one related to biological data analysis, BDA from now on. One related to cognitive, social, and economic data analytics, that is CSDEA, and machine learning and intelligent systems, MLIS, and mathematics of data science, MDS. Okay? And of course, depending on the curriculum, I will show you the details. Okay? And you can, of course, ask questions related to this curriculum. Of course, we expect from students that they have at least a good attitude towards mathematics, computer science, and statistics, but it's not a requirement. I mean, you do not need to have a good background in these areas, but at least you should like a bit these topics. And of course, what we want from you is that you apply knowledge in the practical management of this big data, okay? And of course, you should have an interest in using data science tools and of course, tailored algorithms for the analysis of data and real world problems. Again, real world problems is the keyword in here. So what you should expect from us? Our curricula, as Marco said, are all conceived as some multidisciplinary platform. And every curriculum should enable you guys to properly handle data science model and methods and properly understand the way all those tools are intertwined in big data applications, okay? And in order to do that, you will have plenty of projects and homework that allow you to develop both project management and analytical skills. And that's very important. And actually, we're really proud of our project and homeworks that make you really strong on that side. And of course, we also have plenty of partnerships between industries and research institutions that enable you to implement in practice tailored technique for the solution of exciting data science applications. So you will touch with your hands what solving a real and complex data science application means. Okay? After these 2 years, you should be able to get all these skills, so represent, compress, and store huge data sets, develop suitable models to recognize and analyze data, understand methods, algorithms for handling of big data models, and of course, tackle advanced problems and applications that are based on current research. Actually, this is a big hope that in some cases happened. So we are actually really proud of this. About employment prospects, of course, there are plenty of companies and research institutions that right now they try to deal with big data, and they really have a desperate need for data scientists, and there are plenty of them in ICT, finance, transportation, communications, biology, and healthcare. So you will surely find a good spot in the end. Okay, so about our graduates, of course, our graduates, thanks to the deep knowledge of data science tools and the ability to deal with the computational challenges behind data-driven systems, they represent an effective and attractive professional profile that surely finds an excellent placement in the job market in the end. Okay, so keep in mind this fact. About the main exams, we have these exams that represent somehow the foundations, the backbone of our data science program. We divided these exams in 3 main areas. We have mathematics and statistics, computer science, biology, economics, human and social science. About mathematics and statistics, you have these 3 exams: stochastic methods, optimization for data science, and statistical learning. About computer science, you have foundation of information system, machine and deep learning. And related to this last area, you have cognitive, behavioral, and social data. In some curricula, if you have a good background, you can also decide to replace these 2 guys with some other advanced courses, okay? As we will see in a moment. And here is the list, the detailed list of all the other courses that you can choose in your study plan. Depending on the curriculum, you will have the possibility to choose a subset of these. Right? And do not forget that you also have 2 elective courses. So 2 courses that can be freely chosen from all the courses available at UniPD. Right? So anything you want. Of course, and these exams should be somehow connected with your study plan. Yeah. So let us start with BDA, so biological data analytics. Okay, and this is the first year. The first semester you will have statistical learning, the first part, foundational information system, stochastic methods, and machine learning. In the second semester, you have the second part of statistical learning, and then you will start with some specific exam related to the curriculum, structural bioinformatics and intro to molecular biology. And of course, there will be the first elective that you can choose, together with another of the basic exams that you should take. Right? And here is the second year. In the first semester, you will, or the second year, you will start with 2 courses: biological data, cognitive, behavioral, and social data. Then you will be able to choose 2 exams, one in this first list and one in this second list, that will complete your study plan somehow. And finally, you have 1 more elective course. Right? After this first semester, you get to the second semester and last semester of your program, where you get an internship plus your thesis that completes your path. Right? So keep in mind that before completing your path, you always have your internship together, of course, with the writing of the thesis. Let's switch to CSEDA. The first semester, the first year is basically the same as before. The main change is in the second semester, where you get a different exam in here. You have financial mathematics for data science. And then, as you can see, first semester of the second year, there are some other differences from before. We have the law and data in here. Then we have 1 course between these 3 here: human-computer interaction, cognitive and computation, process mining. And then 1 course between these 3 guys. Right? And of course, at the end, another elective course. And same as before, we have the internship plus the thesis. Right? Let's switch to mathematics of data science. In this case, as you can see, you have the chance, in case you have a good background in stochastic methods, you come from a bachelor in mathematics, for example, you can decide to switch this with advanced course like a high-dimensional probability for data science. Then you have machine and deep learning, that in this case is divided in 2 parts. You have first part in the first semester, second part in the second semester, same as statistical learning. Then to complete the first year, you have optimization for data science, and another interesting example is mathematical models and numerical methods for big data, right? Plus the elective course as usual. In your second year, you will start the first semester with statistical methods for high-dimensional data and then cognitive behavior and social data. One course between these three guys. In case you did not take before high-dimensional probability, you can choose it here. Then financial mathematics for data science and maths, analytical cell biology. Finally, you have one course between these three, as usual, and the elective course as well. And finally, second semester, internship plus thesis. Okay. So let's switch now to the last curriculum, that is MLIS. And this is a bit more complicated, so I will take some more time to explain the details related to this last curriculum. So in the first year, first semester, you can start with statistical learning, of course. These two advanced courses that are highlighted, I will explain the reason why in a couple of minutes. Then you have stochastic methods and machine and deep learning, the first part. In the second semester, you will have the second part of statistical learning, machine and deep learning, the second part, optimization for data science as well, knowledge and data mining, and the elective course. Okay. In the second year, first semester, vision and cognitive system plus cognitive behavioral social data. One course between these three, okay, and one course between these three plus the elective course to complete the path. You finally have internship and thesis. In case you do not have a good background in computer science, you're coming from another bachelor, you might want to take the basic course fundamental of information system. In this case, what you can do is simply replacing these two exams at the first year with this one. And of course, this will be your choice in this listing here. And you will postpone these two in the first semester of the second year. And of course, there will be no elective course in the first year. So this is basically the other option you have in case you do not come from a computer science, you do not have a computer science background. Okay. Let's switch now to the study plan. The study plan is basically the list of all the activities, like exam, internship, and so on, that you must carry out in order to earn the credits that are required for the graduation. Okay? And it can be modified throughout the years in specific time frames. This is very important. You have 2 specific time frames per year where you can modify your study plan. So pay attention to this. Maybe answer to the questions later on. Of course, we have 2 different versions for the study plan. You have the first one, that is the easy one, that is the automatically accepted study plan. In this case, you will basically choose the exam among the ones that I showed you before, and all the exam are activities offered by our department. Okay? And in this case, this is automatically approved once you click confirm plan. Okay? And what happens is that all the activities are immediately uploaded in your transcript. Okay? So this is very easy. In case you go with the required approval study plan, things change a little bit, but it's not that much complicated after all, because this gives you the possibility to include some educational activities that are offered by some other department or schools in the UniPD. Okay? Of course, in this case, the study plan is subject to the approval of the degree program board, the so-called Consiglio del Corso di Studi. But usually what happens is that you send an email to us before, and we discuss about the possibilities that you have. So usually approval is not complicated, right? Not a complicated procedure. Keep in mind, filling your study plan is compulsory, and you must fill it out in accordance with the so-called manifesto di studio of the program. That is basically the list of all the course units that are offered in data science. And of course, you need to keep in mind that when filling in your study plan, you need to refer to the rules related to your enrollment year. Okay. So for every year we have specific rules. You have to follow those rules. About the online procedure, you have an online procedure available for filling in your study plan. So keep in mind this. And the specific time frames I was talking about before are usually November, December, and March, April. So keep in mind this. Because if you go out of these two time frames, that you cannot fill in your study plan with the online procedure, of course. A few words about the Erasmus program. Right? So the Erasmus Plus program basically allows you guys to spend a period between 3 and 12 months abroad. And it is possible, of course, to attend courses and take exams, to prepare your thesis work if you want, or also to carry out some internship work. And we will talk about internship in a while. Of course, as long as it runs alongside a period of study. You can take a look at this website for further videos. You will have these slides available on the website later on. So in case you want to check, you will be able to check this. And here is a list of our partners. Hopefully this is going to be, because right now we only have these two, but we're working hard in order to get these new universities as partners. So for starting next year, we should have all these new partners in our Erasmus Plus program. So you have a better choice on this side, right? So if you have any question or remark at the end of the discussion, feel free to ask. I'm here. And now we switch to the third part. Should be, yeah.
Where is it? Control L. Okay. Okay, so I'll try to be quick. This is about an internship toward the end of your study, will be the second semester or second year. You have an opportunity to go for an internship. This is actually quite good. So you get in touch with companies, you get in touch with research labs, and you start to apply what was presented before. So all the things that you have studied with us. So the host institution for the internship could be the University of Padua itself. So any laboratory, any research lab at our university, any other organizations, such a company that you know, a company that you will meet during our events, and so on and so forth, a research center in other universities as well. It could be located in Italy or abroad, so we are very open with respect to this, okay? Important thing, the host institution that you will pick must be in the career office database at our university, but this is not a problem. In most cases, they are already included in our databases. If they are not, it is a quick procedure that we go through together, and in a second, we will be up and running with a new partner. What is the internship? Is a period of work orientation and training for you, for the student, which does not take the form of an employment relationship. So it will be yourself, the student, who will go through the internship. Then we have the host institution, which will be the company or the research lab. You need to have a company tutor who will be responsible for your activity there. And also, you need to have a tutor at the university. So here, a data science responsible who is going to take care of making sure that you're going to the right path for you in terms of the education process. So this is about the duration. Maximum duration is basically 12 months. This is pretty high. We usually go for maximum 8 to 10 months, but by law, you can go up to 12. You can stretch it up to there. I say cumulative duration because you can have multiple internships if you want. So the standard thing that is going to happen for the students is that they go to a single internship activity, and the typical duration of that will go from 4 to 6 months. This is a typical case, right? And they have a single internship at the end of their study. So I would say second semester or second year, but this is the normal thing. But we are also, of course, open to other solutions. So you can also have multiple internships in case you want to.
For example, you can have one the first year and one on the second, but those are special cases that need to be discussed with the commission. So you need to discuss them with myself, basically with me, and we need to decide whether this is the best path for you. So the minimum duration is not currently defined by law, by the Italian law, but however, we know that doing some numbers here, the minimum duration should be approximately 2.5 months. So we say from 3 months is a real minimum for you to go to have this internship in a company or research lab to do something meaningful, right? When? So usually this is going to be, as I said, carried out during the second semester of your second year, right at the very end of your study, path, and can be at the end of the internship. You could be happy with the company, or you could be happy with the activity that you carried out with the research lab. You can extend it, and you can possibly turn it into a master's degree thesis. So you can extend the internship and work a little bit more on that in a scientific way in order to have a very nice thesis out of it. So also, as I said before, multiple internship periods are possible across different academic years, and we need to, and those things have to be discussed with us basically. So we have a reference website, which is you need to keep in mind, because the main responsible for that is the University Unipd Career Office. This is the website. Also, the slide will be available for you. Now, due to the COVID-19, most of the meetings are basically online or over the phone, but we hope that in the future this will improve. And this office, the career office, is responsible for sending you and dealing with all the official documents that you need to fill and you need to sign in order to go to start and go through your internship period. Here at the University of Padua, at this master's degree, we have a number of partners. This is just an example. We have more than that. We have a number of companies that are collaborating with us every year. And every year we organize an open house, an open day, just for the companies, just for the internship. This should be around November each year. So soon after the summer, we're going to have this event where the companies will be meeting the students. So be ready for that. We will be sending out announcement for this day. And during that event, the companies will be talking about their businesses and how and why they need data scientists. So how they would like to use a data scientist within their teams. And they will have brief talks. We have brief talks from the companies, and then we have a collection of feedback from the data science students, so from you, who will be, will have an opportunity to get in touch directly with the companies. If possible, this year we're going to have it live, in a live situation, not just online, of course. So also important is we set up an information space that we have here at the university. This is the link for the Moodle page at the Department of Mathematics in this University of Padua. If you go to this link, and you will see that there is a special course which is called Data Science Information Space. Over there you will find updated information on the internship rules, in terms of procedure, how to start the internship, how to go through it, how to finalize it. Everything is explained properly there. Also, you will find information on the documents that are required. So this is very detailed. You will find information about the Erasmus program. This is continuously updated, as was said before. And you find more information about other events that we may organize in the future, like seminars, scientific meetings, and so on and so forth. So in order to stay connected with us, I strongly recommend that you subscribe to this Moodle page, the Data Science Information Space, so that you will be receiving announcement, and any time that you want to contact the student, will be pushing announcement to this sort of channel that we use to communicate with you. So the responsible people for this is myself over here, and also Laura over there. And we are basically in charge of staying in touch with the student and one by one listening to what you would like to do, facilitating your internship period by being in touch with the company and resolving any possible problem that you may face. Okay, so If you want, this is my email if you have any problems. So for today, I wanted to be quick, just to give you a brief presentation. And then in November, we're going to have an official event where we can talk for longer, and also meet the companies and start planning ahead with the student who may be interested. So thank you so much. I think it's time for the next speaker. Yes.
Hi. Let me switch. Okay. Hi, everybody. I'm Giovanni da San Martino. I recently joined the department as an assistant professor, and I will teach the course of machine learning at the degree of data science, the master degree of data science. So today I wanted to talk a little bit about machine learning, and I will try to say basically a couple of things. One is try to convince you why it is important to know something about machine learning nowadays. And then I will try to tell you a little bit, in couple of slight detail, what is machine learning. So we just go, we introduce a couple of concepts. So, so let me start. I have this clickbait, little bit clickbait title. So let me start by explaining it. What do I mean by it? So like, if you think about the first industrial revolution in the 18th century, what happened is that physical labor was replaced by machines. So there's been this big switch, and there's been like an increase in productivity and so on, and scalability. Let me use this term. So then the question now becomes, like now in the present days, will artificial intelligence and machine learning actually, will they replace the mental labor, like intellectual labor on the other hand? So is there a parallel between the two? And actually this is why many people consider that the machine learning will revolutionize our society. So, so first of all, this is kind of complex question to ask, and I just wanted to make a couple of points, and I will use an example for this. The first point is this question doesn't ask whether machines will be capable of having very intelligent behavior. The question is about something else. It's about whether they will be able to replace some of the jobs that today can only be done by humans. And the other point that I want to make is that this is not yes or no questions. There's going to be like a progressive switch probably. And I wanted to, I heard this interview, I put a link here on YouTube of an Italian startup called Translated that it is about, as the name suggests, machine translation, so automatically translating a document. And their business goes like this. They get a document, they'll translate it automatically, and then they give it to a professional translator to do the final editing. So when they started, the same in the interview that when they started, the translator were complaining all the time about the quality of the automatic translation, and they were just wasting their time doing a lot of work just rewriting the translations. But with time, they started to have to increase the accuracy with the feedback of the translators, and receiving more data and improving their algorithms. And they get to a point in which the professional translator just have to do some quick editing here and there. So it has been like a continuous process. There's not been a day in which there's been a sudden switch. The other point I wanted to make that this idea of tiny improvements is in the case of this company, it has it's a relatively small company, and it interfaces with professional translators, so the size has naturally is very small. But nowadays we have examples of many companies that rely heavily on machine learning for some of their core business. For example, you have Netflix that has a recommendation system that tells you, suggests you what to watch next, or like even Spotify, similarly what to listen to next. And you have companies like Google and Facebook, which base their business on selling you advertisement. And it's on their interest to sell you the right advertisement, the ones that will make you do the more clicks. In these cases, this company they have a huge market. Obviously, they cannot rely on manpower to do personalized suggestions. So they have to. This has to be an automatic process, and this is why machine learning plays an important role. And even in these cases, even tiny improvements, given the huge market that this company have, like even like an improvement in accuracy to 0.something%, like for Google or Facebook, that might turn out in millions of additional revenue. So so machine learning, that's why machine learning plays a very important role. So you know most of these companies or these products. You heard about self-driving cars for sure. Maybe you haven't heard about Two Sigma. Is a company working on the financial markets. It uses machine learning to support their predictions on their hedge funds on what stocks to buy and so on. And maybe you might have, I'm not sure if you have heard about IBM Watson, which was a system that used to play the Jeopardy, which is a trivia style quiz. And he was able to beat the all-time champions. Same thing happened with AlphaGo. So first simple reason to motivate you to deepen your knowledge in machine learning. These companies are hiring like crazy people that are experts in machine learning, and this is going to be good for your pockets. Okay, so let me go to the second part. Let me give you some ideas on what is machine learning. So I started with a question about the Industrial Revolution, making a parallel between the first one and the current times. Let me do something similar here. So going from traditional algorithms to machine learning algorithms. I'm pretty sure you all know what is an algorithm. It's a clear and ambiguous description of a set of steps to solve a problem. It's a recipe to solve problems. So what happens if let's say we have an algorithm to do the division between numbers. We have an input, so a division that we want to make. We put in our computer, and almost instantly we get in output the correct result. So there are these three elements: the input, the algorithm, and the output. Keep this in mind for a minute. Okay, what happens when we don't know the recipe to find a solution of a problem? Okay, there's nothing we can do. We don't know the solution, there's nothing we can do. But there are some problems that us as humans are able to solve easily. For example, if I give you this problem, if I give you an image and I ask you, do you see a tree in this image or not? You're going to be able to do this. This is going to be an easy job for us as humans. What is going to be hard is to write down an algorithm to solve this problem. So how can we do it? For example, we can try and say, we need to write the algorithm in such a way that the computer understands it. So the computer understands the images as a set of pixels. So numbers that represent the colors of the small squares in the image. So if we have to tell the computer what is a tree, we can describe patterns of pixels and says which one of these correspond to are indicators that there's a tree and which ones are not. So we can say, there's some green, there's some brown, below it, and maybe something like that is going to be, we can make some examples, and this is going to be a tree. Something, if you have different patterns, maybe you say there's no tree. Yeah, it's not that simple. There are so many cases. There are different lighting conditions. There are cases in which there are no leaves because the way the picture is taken. There are trees that have no leaf. There are the same tree in a different season shows different colors. There are trees with a different orientation. So you need to take this into account. This one I would recognize as a tree, but it's green and blue. So if you really start to do this exercise by hand, you get crazy, and you don't. It's really long, unless you have unlimited time and unlimited space. If you have both conditions, yes, if you spend a whole eternity listing all these patterns, and at some point you cover all the possibilities, and that's it, and then you're done. But we are finite being, and we don't have. Hopefully, we want to spend our time also doing something else. So we cannot do this. We need to find another way. So let's try to find a simple loophole. Okay, I define my pattern as the whole image. I take a whole image, I database. I don't know how to answer. Again, if I have enough time, I can have a huge database, and that is fine. If I don't have enough time, I'm gonna run into a problem. I cannot generalize to unseen examples. So having this loophole of just listing the images, so memorizing the input examples, in other words, doesn't work. It's like when you have to study for your exams. It's not a good idea to memorize the exercise. You need to understand them, because otherwise you're not going to be able to do the new one on the day of the exam. Okay, then what we can do? The idea is we need to go back and find these patterns. That was my first proposal. But instead of doing ourselves, we can ask the computers to do it for us. And we can set up the problem in this way. We can still have an input, which is our image, as before. We can define an output, which is like, say, 1 if there's a tree in the image, 0 if there's no tree in the image. And then I can ask the computer to determine automatically what are the patterns. So I ask him, look for all the patterns, do a quick search in all the space of patterns, or maybe like a reduced space. That's even better. And you look for the ones that appear in one class, so when they're correlated with trees, but not in the other ones. So these are indicators there is a tree and so on. And then the computer can make us, maybe in a reasonable time, this list, and then we can use this one. So if you compare this image with the previous one, you see the elements are rearranged. So the input is still here, but here before there was the algorithm that goes in, and we have the output. Now, what do? We take the input, we take the output, and we try to devise the algorithm, which in our case, in our example, is this list of patterns of pixels. So this is the difference schematically between classical algorithms and machine learning ones. Okay, so let me go a little bit, let me add something. Let me complicate things a little bit. Okay, so let's try another example. Let's say that I have as input values that represent the weight of something, and I want to predict the corresponding height. So I have this list of points, and I want to be able, given any value for the weight, to be able to predict what would be the correct height, whatever that means. In machine learning, we usually do one thing. We take our data and we divide it in 2 sets. It's going to be clear why in a second. The one set is called a training set, and this is the set of examples that in which I search my patterns. The set of pixels of the image, or in this case, these points, the parameters of my model. And then we have a test set that we're going to use in the end just to have a confirmation of how good was this model that we found, like a further confirmation. We don't use this one for statistical reasons, and this is going to be clear when you attend the courses. Okay, so we want to infer what is the right relationship between these two variables, the input and the output one. We need to choose, so basically we are going to do a fitting in this case. I'm really simplifying things here. And we need to choose the shape of the fitting. So for example, we can have just a linear fitting. These points are my training set, and I take the linear fitting that best fits the set of points. Let's say that this one is, believe me, that this is the one, the line that is output. If I then try to see how good is this line, how good means like how, what is the distance, average distance between these points in this case. I can see how good it is on the test set, and say that the performance are kind of the same. In this case, the line, as you can see, is kind of simple, model, and is not able to fit perfectly my points. And this is translated to say that if I take a linear model, it has a low bias because it's not really able to fit well the points in the train set, which is not necessarily a bad thing, because we are not sure. It might be the case that these measurements are there's some noise in the measurements. For example, the person who take these measures maybe was short-sighted, so he made some mistakes here and there. So maybe we shouldn't trust 100% all those points. As you can, and then you can see, you can take a more kind of logarithmic style curve, and this seems to be fitting more our training points. And then, okay. So if we take a more complicated curve, this seems to be fitting more our points. So can we push this further? Can we have like complicated lines that fit perfectly, that is very squiggly and fit perfectly my training points? Yeah, why not? This is a bad idea for this for the same reason. I'm trying to give you an idea here. So if I take this. If I learn this line on our training set, and then I try the same line on our test set, so just the green points, while this fit perfectly our training set, it makes quite an error on the test set. So only fitting our training set is not the best strategy, because there are other points we are not considering, which are like the points like. Which I was referring to as like those examples that they're supposed to generalize to when we're supposed to generalize to unseen examples, in which we want to perform as well. So having a very complicated line is not a good idea. And in this case, just again introducing some terminology from statistics, we would say that this type of curve has high variance, because if we change the set of points of our training points, the curve will change a lot. While the linear curve, as we've seen, doesn't really change much, because it's not powerful enough to adapt to the training data. This one seems to be has more freedom to adapt to the training data, but to the detriment, in this case, of accuracy on the test data. So the main message here then is that the first algorithm that we have seen, the one about the images, I was just saying we try to find this correlation that best fits our training set. Here in this plot that I've just shown you, I try to give you the idea that fitting the data that we have is not enough. We need to ensure that we are going to perform well on data that we have not seen. And there are lots of mathematical formulation to express the relationship between some models and their capacity to generalize to unseen data. But in general, so we need to make a choice on what type of model we want to use. So if we go back to this example, what type of curve we want to use? If it's a linear, if it's the second one, parabolic curve, or if it's the one that's very powerful and fit all the points. This is a choice that we need to make before, and usually this choice is made in such a way to avoid this case, because it does not give guarantees on data that we have not seen. There are many of these assumptions, and as I was saying, all of these have associated their own generalization bounds on data that on unseen data. These assumptions lead to many different algorithms, and each of these will be each of these will be optimal according to how well the assumption fit the real data that we want to actually predict. So in other words, there's unlike other fields, there's no an algorithm that is better in all possible contexts. Depending, actually, there's a theorem called the no-free-lunch theorem that says that if we take a machine learning algorithm with its own assumptions, again, to limit the power of the model, we can work out against this assumption and make it create a task on which it performs really bad or really good. So this is to say that again that the machine learning field is a very big field for this reason. There are many different algorithms that work in different contexts, and it is important to get a feeling of which one works well in certain conditions. So another point I wanted to make, I'll try to be brief now, is about big data. So nowadays, many learning problems can use very large amounts of data, and this implies that the algorithm that we implement needs to be extremely efficient in dealing with the data, with this data. So this is also important to be able to code very fast, to have very fast code, or to know which libraries to use. And one last point is, if you remember the slide with all the applications and the companies. So since nowadays machine learning is used in so many different applications, so many different contexts, the simple performance of the simple accuracy of the model is no more the only measure to take into account. So for example, in some contexts, it is very important to understand how why a model took a certain decision. So we need to be the model needs to be able to explain. This is as important as to be able to explain why it takes some decision. It is as important as actually the accuracy of the decision itself. If you think about a system that should support doctors in their decisions, the doctors will never trust the system. They just say do X or do Y, unless it explains the whole reasoning that took him there. Okay, so to conclude, just to say that, so my points here in this talk were to say that nowadays machine learning is the core of many internet companies, and they do a lot of they invest a lot of in machine learning, and machine learning is nowadays used in very large number of different applications, some very far away from the other. And I hope I give you an idea of how vast and complex is this subject to study. Thank you. Nicolo, you have a presentation. Yeah, you're ready.
Thank you. It's a successful story.
I guess it's a good story. Definitely a good story. L'avevo messo mai sul browser. Sì, l'avevo messo sul browser. Okay. Okay, thank you. I guess I can start. Yeah, I guess I can start. Okay, so my name is Nicolo Ruggei, and I'm just a former data science student here in Padua. So today I won't give you any more technical detail about the degree. It will just be a story about me studying data science and where I went further after this. So it's just an idea an example to explain what one can do during and after the data science course. Before I start with the whole story, something about me. I was born and raised in Padua, academically speaking at least. So I studied mathematics at the Department of Mathematics, and my thesis was just in probability, which was really cool already. And then I just decided to go on with the data science course, which you also are really gonna take after this presentation, with a final thesis in variation inference. We'll explain a bit about this afterwards. And in hindsight, I guess it was a kind of coherent story. Mathematics was a good playground for me. It was really interesting, and then going on with data science just allowed me to apply many of the things I learned during my bachelor for the master. Now I'm currently doing a PhD at ETH Zurich, which is a nice university in the northeast of Switzerland, and Max Planck Institute, which is another very nice institution in the southwest of Germany. So it's a shared PhD between these two institutions. And here, this is where I go with what I did during my master. So during my master course, what I did, what I studied, and afterwards I'll tell you about what I'm doing at the moment as research. So before we start my data science journey, I would like to highlight that this is my data science journey, which means that, as you probably have gathered from all the presentations before me and the professors, data science is really huge. And I guess it's really hard to know everything about data science altogether. And this is what I wanted to say, yeah, this is one of the possible paths one can take. Whatever. Many of my former peers during the data science master took different paths in life.
And I know for a fact that they're really happy, just taking a different way, going somewhere separate. With that said, I'll just explain you what my courses were during my master, which I think that they highlight the backbone that also Professor Rinaldi explained before. And even without coordinating about this, I guess I came up with the same separation of courses in big topics. So there was some mathematics, the basic mathematics you need for data science, and in my case, a bit more tailored towards numerical methods for big data and machine learning in general. So I took stochastic methods course, optimization taught by Professor Rinaldi at the time, and some other courses in mathematics. And then, of course, other stuff came from more applied to machine learning, so more tailored not to general mathematics, but machine learning applications. And these were the algorithmic methods and machine learning course, which you also have, the statistical learning course, which is very similar to the one I took, I think, and the human data analytics with Professor Rossi at the time. And after I went on with the other skills that I guess you can expect from a data scientist. So some IT skills, some coding, definitely. And this is basically what's encompassed by the fundamentals of information system course that's going to be taught in the first year. And this is really useful. For example, I'll show you one of the projects I'm working on at the moment where I basically exploit almost all of these. And then finally, some more applicative courses where you try to exploit all this knowledge and apply it to some data coming from different scenarios like biology, social science and finance and so on. Okay, so this is kind of what I learned during my master, and then there's a part of what I did during my master. So this is the first internship I took in between the first and second year. It was the summer between the second and third semester. And I guess I have to point out, this does not count as my internship during master. So this is a separate thing, which I just decided to do on my own. It was kindly supported by the university's Erasmus traineeship program, which you can apply for many times. I think there is a maximum of months you can obtain during master, but I'm not quite sure what the maximum of months is now at the moment. But the experience was very fulfilling. I went to London working with this small startup that were called Deary, and they're still there, still working on this stuff. And the idea was to build a mobile app, basically, where they take some messages and through some natural language processing and other machine learning techniques, they try to classify the messages. This is what is also called, at least in their application, this is called sentiment analysis. And I guess in terms of skills that I acquired during the internship was a lot of extra coding, building on top of the basics I had learned in Python during my bachelor in mathematics and during the course I took during the data science master. I had to code a lot, and then there was some extra machine learning to do on top after we came up with the first simple structure for the code base for the stuff. This was really fun. It was amazing, and I guess it's a good experience overall. And then second, my actual formal internship at Max Planck Institute for Intelligent Systems, which is also where I'm taking part of my PhD now. This is the formal internship that you need to have for your degree in data science. And at least during my thesis now, and I'm switching a bit my research topics. I'll tell you about them more afterwards. But in my thesis, I was working on network science, which is basically a branch. It's a branch a bit outside machine learning. It's the main core of machine learning, where you try to model big data through the usage of graphs and networks, and some probabilistic learning, which was in my case some Bayesian inference and some Bayesian modeling on top of networks and also outside the network modeling scenario. Okay, so this was my experience. It was real fun. My two experiences during the master and my courses, and now just again as an example of what one can do if they want to during the data science master and with the data science skills they acquire here. Some projects I'm working on or have worked on in the past, which I think I chose because they're very explicative of what one can do and they're very representative of something I like from the data science skills. Okay, so this is one first project I'm working on at the moment. And this still falls under the network science kind of label, I think. I'm working on this with my supervisor from Max Planck at the Bacco, which I got to know during my internship for my master thesis. And the idea here is that you just go on Twitter and try to sample some data. As you can imagine here, there's a lot of coding involved. And the idea is that after gathering all the data from Twitter that we need, with a huge code base, we're still working on the code at the moment, which involves a lot of Python, of course, scraping the Twitter network with different APIs or by building the scrapers yourself, and a lot of database because there's data to be handled. Well, after this stage, the idea is that we're gonna try to come up with a probabilistic model for modeling how hate speech propagates through the Twitter network. This is real fun because if you like coding, this can be real fun. I guess a nice way of spending time. And after the data collection phase, we're going to do some statistical modeling. We're going to model the Twitter network as a network, as per name, and try to see if our probabilistic models manage to feed the hate speech propagation on the network. Of course, this is not an idea of ours. One does not just come up with this by themselves. We have collaborators, and especially some sociologists in Santa Fe Institute, which are really interested in how hate speech in general, more on the sociological perspective, propagates and affects real life. So this is the first stage of a multi-stage project where first the probabilistic model will try to explain how Twitter behaves in terms of hate speech propagation, and then we're going to connect with further probabilistic modeling this hate speech propagation with real life crime data. So the idea is that we're going to see if there's a correspondence or at least some correlation between the Twitter network, which is completely virtual, as you can imagine, and the real life crime data, which we have from our collaborators and sociologists in Santa Fe, and all together try to come up with an explanation of how these phenomena behave. So this is the first project I wanted to mention because I think it's very explicative. You see, there's a lot of coding, there's statistical modeling, there's inference, there's a lot going on. And this is all stuff that I guess at least the basics I gathered from my data science course. So this is really interesting. And then I would like to tell you about some other things I'm doing, some other projects I'm working on. This still went with my supervisor, Katerina de Bach and Max Planck. This first idea is just working on probabilistic learning. This was my master's thesis, which was separating two things, the network science part and the probabilistic learning part. And here, this is an example of something that's very trendy at the moment in machine learning, which is called variational autoencoders. This is basically the classical version of Bayesian learning and Bayesian inference, which is more, I would say, in the old days, was more tailored towards pure statistics and pure statistical modeling. And nowadays it's moving a lot also towards machine learning. And this is a nice intersection between what was more a core machine learning and more a core statistical kind of scenario. And you merge them through Bayesian modeling and deep learning. So variational autoencoders fall under this category of models that try to model densities in high dimensional data. Which you're also going to see if you take some of the electives in the courses of the data science master. Because the idea here is that, as was explained before nicely during the other presentations, if you have big data, it's really hard to come up with a proper algorithm to model the data and to classify the data, but at the same time, it's really hard to come up with something, for example, that can generate realistic faces just without just by hard coding the algorithm that generates the faces. So variational autoencoders fall under this category of models altogether that try to model high dimensional data and try to generate the data. So these, for example, are not real faces. These are faces generated by the variational autoencoders paper in 2013. But generate new faces which don't belong to anybody, just faces made up from the computer. And as you can imagine, this was 8 years ago. By now, the generation is crazy. They're really good. And the idea here is that variational autoencoders are a really nice intersection between deep learning and Bayesian modeling, but they come with limitations and with approximations. So in general, one can come up with any really nice and fancy Bayesian model or any statistical model for that matter. But then the difficulty is to come up with inference. So the difficulty is to come up with the right weights or parameters in general. Something that, at least in the basic form, you're gonna learn during the statistical learning course, that allow your model to generate or explain the data properly. And since variational autoencoders have millions of parameters because the neural networks in the end, on top of some stochastics. They come with limitations and approximations. And the idea here is that during my project, I wanted to improve on the learning procedure by coming up with better approximations that allow you to generate, for example, heuristic images or other applications of this stuff. So this is the second project, and this is something a bit more involved with that. I guess there's no value for now going into deeper details, but something that's really fun and that's really interesting, and I would say really trendy nowadays, machine learning. And then one third branch of research I'm working on is something a bit more pure, which is called deep learning theory, which is basically something on top of the very short encoders and deep learning. Because we have these big machines, they're called neural networks, that basically at the basis of all or many of the machine learning algorithms that are employed nowadays in the state of the art. And they work very well in practice, but then the thing is that we don't really know how they do this and why they work so well. For example, you were explained before about the bias variance trade-off, at least on a very high level, where you assume that you should have a model that's not too big, not too powerful, otherwise it will just interpret the data. But at the same time, you want something powerful enough so that it can model the data decently. Well, machine learning and deep learning, especially in the last 2 to 3 years, they noticed that these machines are huge. They can fit any training data set. So basically the interpretation kind of scenario we're seeing before. And still, for some reason, which is, we're getting to an explanation nowadays, but still not completely clear, for some reason they can interpret the data and generalize very nicely. Meaning that, for example, they learn a data set by heart, and at the same time they can see a new image which they've never seen before and classify it well. So this is something that I'm working on at the moment. It's part of a bigger picture about understanding deep learning and making these machines more reliable, maybe understandable. Maybe we can explain them by white boxing them in a sense. They're called black box models because we don't understand what they do, the mechanics inside them, and now we want to understand why they do it. So the classical statistical learning theory is falling a bit behind in this sense, and now in the last 2 or 3 years, there's a plethora of papers that try to understand what's going on with deep learning, on a more theoretical basis, to move on to applications afterwards. So this is just me explaining some stuff that I'm doing at the moment, which I hope is representative of what one could do if they chose this given path. But on a more high level, I would add a personal note, which is just to have fun doing the master. I would say that, especially given the very international environment here, something very precious is to just connect with your peers and have fun in the city, because it's a very young city. And one should have fun. One, it's your life. Two, because it also improves productivity at a certain point. Well, it depends on the point, I guess, but after you've studied too much, you should also take a couple hours off. That improves productivity. So just have fun during the science master, because it's a very interesting field as well. And I guess you're gonna like it a lot. So I guess that's it.
Hello everyone, I am Martina Condisciani, an ex-data science student. I'm very sorry not to be there today. I would have loved to go back to Padova, but I still hope this video is going to be helpful for answering some curiosity or to some question you may have. So these are some information about me. I have a bachelor degree in statistics for business and economics. I have a master degree in data science. And right now I'm a PhD student at Max Planck Institute for Intelligent Systems in Tübingen. That is a very small village in the southwest of Germany. You may be curious why I changed from pure statistics to data science. And the main reason was that because at that time I was intrigued by the algorithmic and computational complexity raised by this amount of data we have easily access to. And I was also curious to study the techniques to handle this amount of data. And this was what was offering by this master course in data science. And actually it was also the first year of this data science master course in Padua. And it was a very nice experience, and I graduated successfully in 2019. And I'm very happy to tell you my story and to tell you my experience. I will summarize my experience with the 5 things I like the most during these 2 years. First of all, there is the building. I love this huge cube in Padova, where basically it is the core of mathematics. And there is a lot of science going on there. So if you want to do science, that is the right place to go. And also it's very close to the river, where in summer there are going to be bars and music. Being very close to this place after very long days of studies is a very plus. Okay, jokes aside, I love this course also because it was able to build a very intercultural environment. I'm honest with you, and for me it was the first time I really worked close with people from different countries. And this helped me to grow, both from a personal point of view, but also as a scientist. Because when you have to work on a problem, basically having people from different countries helps you to see this problem from different point of view. Maybe some point of view that you never thought about. And this is actually what happened for me. I noticed that I was biased with my culture, and in this way, thanks also to this course, I started to be more open-minded. And another point very important to me is the fact that this master course is very interdisciplinary. This is one of the main selling point of this course, and I want to highlight it even more, because I found the main course like stochastic processing, optimization, statistical learning, and all the course in computer science very important to build my toolbox. But then I had also the chance to choose the main tool or the most suitable tool to solve problems in different disciplines. And this thanks also to courses, for example, in biology, in cognitive science, or in business and economics. And from one side, these courses helped me also to understand which was the path I wanted to take, or which is the area I'm more interested in. But also having the chance to explore different problems helped me to be more, let's say, also here open-minded to choose the tool that better solve a given problem. And the second point is very related to the third one, because this interdisciplinary comes in also with with projects. And actually in this master course, we had many different projects to complete our courses. And I really love this part because, yeah, you never learn until you have your hands dirty. And at least this was for me. And yeah, in this occasion, you have a main problem, and alone you have to be able to solve it with the toolbox that you build thanks to the other courses. And for example, one of the projects I developed was in the course of knowledge and data mining, that we had the idea that including logic and rules in the neural network would improve the performance of these neural networks. And this was exactly the case, but of course you have to prove it through experiment, through a very stable model. And yeah, of course you will encounter many problems, but then also, I mean, you have to be able to solve this problem. And thanks to these projects, I'm sure you are going to be able to do that. A more applied project that yeah, I would like to tell you is the one I did in network science, where I analyzed the political agreement between politicians inside the EU Parliament before and after the Brexit referendum, because I wanted to see if some politicians changed their mind or like became more extreme given this political event that happened. And this was exactly the case. I found I used community detection approaches to study those networks, and yeah, at the end you really see that some politicians become more right side apart, and was yeah, was very interesting because yeah, as a humans we have many questions and many ideas, and then through maths and through statistics and through data science, we are able to answer these questions. Yeah, I could go on here presenting the other projects I did, but actually I want to present the first point of this list, which is the internship, because yeah, this is basically very related to the project because it's a 6 months project. And at that time, I didn't find many master courses that offer these possibilities. That a posteriori, I'm still convinced that it's a huge possibilities. And yeah, I mean, basically that's why it's on top of my list. Here you have 6 months where you can dive in your project, your idea, and yeah, challenge yourself to write a master thesis. And the master course in data science in Padova has a very good networking because I have contact with very good companies, also top research institutes, and this is a very good trampoline also for the life after the master degree. This was at least from my experience, because I went at Max Planck Institute to do my master thesis, and then I had the chance to stay there also for starting my PhD. The group is called Physics for Inference Optimization, and my supervisor is Caterina De Bacco. And this group, as spoiled by the name, has works on two main area. So there are people working on routing optimization on network, and yeah, there are other people like me that works on inference on network. Yeah, long story short, means that we try to describe networks data through a probabilistic model, and we try to encode in the model parameters some knowledge that are able to describe the system that we are observing, and also that will help us to make future prediction. Even though we work with the two different approaches, the main objects we work on are the networks. These are mathematically speaking, they are graphs, which are basically a collection of nodes that are these individual elements here, and edges that are interaction between these individual elements. And this is an abstract representation, and that we can study with mathematical models. We can study also the mathematical theory of or property of these networks. And this structure is basically a general tool that we can use to study systems of different disciplines. And here is where interdisciplinary comes back again. So that's why I also put in my list, because I found very powerful that an abstract tool like this is able to, or can be used by different people working in different areas. And the approach I take is usually, I see some data that are described exactly from a graph, which is a collection of nodes and edges. And I ask myself, why do I see this data? Like, how this data can be generated? Because at the end, I would like to develop a model capable of describe the data I am seeing, and I want to incorporate or like to encode some knowledge I have to this data through latent variables that are variable that usually we don't see in the data, but we try to infer from them, that allow us to generate data similar to the one we see. So that's why it's a circle, because usually we start from some data. We don't know how they are generated. So we try to, we make some assumption, and then we develop a model. We try to infer the parameter of the model, and then we try to test if this model is right by generating data and see if these data are similar to the one we are seeing. So this is more or less the main idea or the main approach I'm using. And I just want to briefly introduce two main projects I work on in the last year. This was also the starting, let's say, I started this project during my master thesis, and here I work with an anthropologist. She provided the data, and she gave us a network with the interaction between nodes, and she gave us also the metrics with the information of the nodes. And we were curious to know, like, we wanted to describe why we see this data. So she want like some model able to reproduce this data that somehow tell us why we see this data. So the assumption that we made is that there exists a hidden community structure that determines both the interaction between the nodes and also the personal informations of the nodes. So in other words, we can say that given this network and given this matrix, then our goal is try to find the partition of the nodes among the communities, together with the other parameter of the model, of course. Here is just to give you an idea. And so given this data, these two sources of information, we were able to partition the nodes in these communities, overlapping communities. And then the powerful thing of data science or science in general is that of this approach is that we were working with an anthropologist. So we presented this data to her, and she helped us to interpret the result we had. And they made sense. So I was, of course, very happy, and this, motivated me even more to follow this approach. With another project that describe the reciprocity network. This is also a question that sociologists ask between themselves, because usually models are not very able to reproduce data affine with or data with properties of the real data. And basically because when we have directed networks, in this case, a single layer network, the existing approach say that the edge between this node and this node is independent from the edge that goes from this node to this other. Well, instead for us, this is a too strong assumption. So in this case, our assumption is that these two edges between the same pair of nodes has to be dependent between each other, because I mean, the fact that I have this edge will increase the probability of having this other edge. So this was the main motivation of this project, where basically we encode this idea of dependency between these two edges by modeling the conditional probability. So in this case, we are modeling the fact that the edge from I to J depends, is conditioned on the presence or the absence of the edge from J to I. In this case, so the goal was to encode this reciprocity, which is exactly the tendency in a network to have reciprocated edges in a probabilistic model, able also to reproduce data with a given reciprocity. And in this case here, we analyzed the Erasmus network data. So nodes here are university, and the edges in this case are like interaction between university. Of course, there is more information in this case, but thanks also to this approach, we are able to say that here the target university is a university in Spain, in Madrid, that basically this edge is blue. So in this case means that while this edge sends student, while this university sends student to this other university because it finds that they belongs to more or less the same community, this other university send other students to this to the Madrid University only for a reciprocity effect. So basically, we are able through this model to study pairwise interaction and see, for example, in the red case, is the opposite case. So it's like, is this university that sent to students to Madrid because it finds that they belong to the same community, while instead Madrid just sent back students because of, because of the Erasmus partnership. So with these two examples, I just wanted to give you an idea of, of the approach I use during my PhD, and how data science helped me to deepen my knowledge and to be more applied and more interdisciplinary. I really thank you for your attention, and please, if you have any question, just send me an email. I will be more than happy to reply to any kind of curiosity, question, and everything. Thank you again, and goodbye.
Forse lì da qui.
Just one question.
C'è questa roba di Laura.
Yeah, sorry. Can you
hear
hear me?
Yes.
Okay.
How many questions? One? Maybe on YouTube, more questions.
Sorry, I can't hear you.
Laura? Can you
Yes,
hear me?
now I hear you.
Okay,
Thank
perfect.
you.
Sorry.
Thank you.
There are other questions on YouTube, maybe, because on Zoom we have just one question.
Mm-hmm.
Can you
Okay.
check, please?
Yes, I'm checking. No, I can't see any questions.
Okay.
There is no questions here. No, there are no questions at this moment.
Okay, and there is just one question here in, can display this. Okay, I received the rejection mail stating that I didn't have the application. I'm sorry. For the new application. Okay, can you answer?
We evaluated.
Yes.
I'm sure that it was evaluated properly, and now with the evaluation committee, we need to go through it once again, but it should be a reason. It's just a matter of maybe answering the student, so we will be aware of what he or she has to improve into the future in order to
Yes.
become eligible.
Yes, we have had many applications.
Yeah.
Almost more than 1,000 applications, and we select up to now 80 students. And so not to require, maybe the answer is not the minimum requirement.
We need to look into that carefully.
Yes.
So Laura, if you can take the name.
Okay.
So we will check and then we'll make sure to provide a precise answer to this applicant.
Okay, we have another question.
Yes, about this. So you just said that at the moment you take around 80 students per year, but in the presentation you said that there are more than 100 students applying already for this year. So I'd like to know how were they, why do you choose students in respect of another, which parameters are taken into account for the
The 80 students are international students plus students from the University of Padua. This is a different story. So we have two channels, right? And so the 80 for now are the international ones.
So that student, there is no more any fixed number of applications that we accept. It's free, and so you have to meet the requirement, but if you meet this, you can enroll free. Okay. And so there is not a higher number. Yes,
There is not yet a critical number or cap for the Italian student that we can get, but there is a critical number and a cap on international student that we can get.
Yeah, I was asking because I just taking a look at the statistical data of the University of 2020, and for that sense, there was only 18 in the previous year. So I would like to know which is the reason for this difference from the outlines that are hundreds of students that are graduates or
we are growing up very fast. Students that graduated are students that start 30 year. In the future, we have much more graduate students. Yes, you're right. We can make some statistics, but the number are so small and so starting for the rate. How many students will finish? I think that the rate is very high. Maybe some student takes some time to finish, but we have this rate. But
the rate is pretty good right now. And all the ones that start with everybody.
Okay.
We started in 70.
Yeah, those ones, I think most of them are the way.
Okay.
Maybe Laura, you have.
I have the email.
Statistics already out here. And then the new books is growing up every year. It's almost 30–40% more than the previous year. So it's not easy to make statistics. That means, yes, you can say virtually, but if the number, the input is increased, it's possible that I don't know, there is not the same proportion of students that, so I don't know, it's a changing sample at the time. So I think that just in 3 years it will be okay. Okay, sorry. You can listen as. Okay, Laura?
Yeah, please, if you use the microphone, probably, because we can hear you.
Sorry, I forgot.
Thank you.
And there is other things that you want to add, but I answer about the rate of graduated students. We have numbers of how many students have been graduated until now for data science.
I don't have this number right now. If you want to, I can check, even if surely in this academic for 2021 or also in the past years.
Okay, just up to now, because I think that we have statistics, but we will publish this more properly on our website.
Yes, we can publish it on the website, because right now I don't have the right number. So I can inform you in detail with an email. So no problem.
This is for Sadi. We said that we are going to inform you via email.
Okay. About the rejection.
Yeah,
sorry, because
you were not eligible.
I wasn't
so that
here.
You will know.
Okay,
yes.
Because I wasn't.
Yes, and then we were also saying to the students here in the classroom that the process has been very selective, especially for foreign students, because the number of applicants that we are receiving has increased substantially in the last few years, going from like 50 to more than, you said, 1,000 this year. So it's becoming very selective because we have a cap, a maximum number of international students that we are allowed to take yearly. Okay, so we do not yet have a cap, a maximum number on the Italian student that we are allowed to take, but we have a cap on the maximum number of foreign students that we can enroll. So this is why it's becoming very selective. So you may be eligible in terms of paper and courses that you have attended, but there is a committee that is evaluating, what you have done, and also the scores and the grades and everything. So that is becoming selective.
Thank you. Yes, exactly.
Okay. Thank you very much, because I can, before this time I couldn't hear you. So thank you.
More questions, Laura?
No other question on YouTube. No questions. And
the classroom will have another question.
I mean, the same question. The science must be why some choose data science over intelligence, the science and the master degree, which are the big difference between the two. So what's the reason to choose one or another?
Okay.
I suppose you have to repeat the question.
Yes.
Doesn't look like later.
Okay, if I understand well, it's the question is why to choose. We have a similar curriculum in the computer science master degree on artificial intelligence, and so the question is, which is the difference? Why to choose data science instead of computer science? Okay, I have to say that because data science is much better than computer science, but it's not. I can't be too sincere. It's different in the sense that we require more mathematics, statistics, instead of what is required in computer science. Computer science is the continuation of a bachelor in computer science, and so they make some adjustments to your preparation. They add some brick on artificial intelligence or other topics to your knowledge, previous knowledge. It's more, I don't know, it's more challenging to come to data science because you really mix different topics, different people. You mix up with mathematicians, statisticians, students, and people coming from biology and so on. So it's much more multicultural environment from the side of the students and the professor. Probably it's more difficult at the beginning, but you are forced to acquire more knowledge on topics that maybe in your bachelor was not so emphasized. And so you have to study more mathematics than in the computer science master degree. And but which, as you have seen, heard from your former classmates, it's possible future. Okay, it's complicated to explain. And this is very stimulating for you because you understand the different way to solve problems and techniques, and you have to do this really following courses in these topics. And so this is very future, in my opinion. This strong interdisciplinarity is what makes things possibility to solve more difficult problems and fight this because you need different approaches, different knowledge, previous knowledge. And so it's something that I suggest. But for sure, if you will have had a very good experience in your previous bachelor, it's very, very natural to continue in the same place where you grow up, and if you appreciate this. If you have more, have a feeling that maybe you can want to learn new things from a different perspective and to be more challenged in your skills, and so maybe come to data science is a good choice for you. Many students choose to come here, and we are really attracting, and the students, international student that arrives without any previous bachelor done in Italy, so outside from the Italian system, will appreciate the data science very much, and they recognize that really we have the curriculum in cognitive that is not so easy to find with all these basic mathematics, statistics, and computer science, machine learning. It's easier to find some of these topics, but in an environment that is no more so strong for the other topics.
I may add.
Yeah, yes, please.
I am a professor originally from telecommunication systems, so I'm coming myself from a different branch of science. And in my path, I choose to move towards data science more and more because I found it stimulating in terms of all the statistical things and data analysis tools that I like. So the difference is that we also in telecommunication, we have a curriculum about more oriented towards machine learning. And I believe any master degree has now a curriculum which is more oriented towards machine learning. So the difference is in any other curriculum, there could be like, I don't know, as you said, computer science, for example. You take computer science as a main, and then besides that, you're also looking into the machine learning field for sure. Now, machine learning is becoming ubiquitous, so you have it everywhere for every single, scientific project or any problem is now dealing a lot with machine learning, and it's going to be used in every sort of application. So when you're choosing data science, you're looking at the center of the study. You have the science of data, the machine learning tools, the statistical learning tools, deep learning tools. So you put at the center of your study all that, so the theory and the tools for that. And towards the end of the study, you may specialize, usually doing the thesis, and start looking at some application with the internship and maybe with the master thesis. So it's a different sort of approach. I believe, as Marco said, you're getting much stronger knowledge about the fundamentals of this theory. And then later on, you may specialize in many other very nice and very good curricula that we have here at the university and also master degrees. Maybe they are more specialized on a different topic. And besides that, you're also getting quite a good knowledge about machine learning, but not all of it. You will be, for sure, looking into some specialized, tools that you need for that specific, branch, for example. This is the difference, but I believe it's quite natural. Yeah. This is why we decided to create this new, young data science master degree.
There is another question. from
Yes.
YouTube. Hi, I'd like to know if it's possible to access all the curricula having a bachelor degree in economics, or if I can access only the cognitive, social, and economics analytics one.
Okay, no, when you, I think that is an Italian student, this one asking.
Yes.
Okay, if you enter in the data science, you have not forced to choose a specific curriculum. We accept you to data science. Then, depending on your preparation, probably you will be more close and you will prefer to choose the curriculum in cognitive, social, but you are not absolutely forced to do this. You can choose mathematics or machine learning or biological data analytics. So just after you are enrolled here, you have in the second month in November, you choose and you can change your choice later, which curriculum is more, do you like more? But yes, it's possible to change if you change your mind, and it's intended to, we try to make all the curriculum that are accessible for all students, adding some bricks, some exams, some or having the suggestion to change with something more specific, more advanced if you have already the basic knowledge of some of these topics. But it's completely, if you enter in data science, then you can choose any of the 4 curricula. Yes, please.
I add something. The choice of the curriculum is basically connected with the study plan, okay? It's a different way of calling the study plan in the end. So if you change your mind, as Marco said, you can always choose in the middle of your way a different curriculum. Okay? So you always have the chance to choose in the specific time frame. You can make up your mind and change if you want until the end of your path. Okay? So this is a very important thing. But of course, if you have a background in economics, maybe you might be more interested in the curriculum related to cognitive and economics. But this is not, of course, something that we force you to do. Okay? It's always your choice.
Okay, perfect. Laura,
another question. Usually, what is the bachelors of the students that come to data science? Also, are lessons in common with students of other departments?
I am not sure that I understand exactly what you said. The audio is not so good. Can you repeat, please?
Yes. What is the bachelors of the students come to data science? The required bachelor.
Okay. Oh. You want me to answer or you want?
Yes, if you know the answer.
We have plenty of different guys in here. I mean, we have people with bachelor in biology, psychology, statistics, physics, computer science, engineering, mathematics. So there is really a good mixture of bachelors in here. And this is actually a very good thing. And this is also a good reason for being here, because you really can have, connect with people that have a different perspective with respect to the ones you have. So.
And another question was, are lessons in common with students of other departments?
Please.
Again, yes, of course, there are some courses in common with computer science, engineering, mainly. I would say these are two main, but we also have some with mathematics engineering, some other with mathematics. So, and actually, in principle, there might be people from other programs that simply choose your courses as elective. So there's always this chance. So it's a good chance that you find people from other programs. Yeah. Any other question? No? Okay.
No,
Be with you always.
no other questions.
Paola, other questions, or we can
No,
close
no
here?
questions.
Okay, fantastic. We can close. We will make a correct changing the name of one of the speakers that is wrong, but I'm sorry. I apologize.
One question again from YouTube, I think.
Oh,
Where?
another question? No.
No, I see only thank you very much from the student, from one of the student.
Okay. Okay, I thank you, the students here, the 2 students. We are no more used to being present in person to the places, but we will have to do in the future. And thank you very much for the question. And I hope to see you next October here as students. And to everybody from home, thank you for participating, take part, or to watch this recording later on our webpage. And I hope that it will be more clear what is the master degree in data science, which opportunity for your future it offers. And I'm sure that if you will decide to come here, you will be satisfied and you will help us. Have you seen Turkey made a place where we are is one of the many reasons to be here. So I hope that you will agree with your classmates and to be here. But I'm sure that we have the problem will not be the number of students. There will be many students, and I hope that we'll be able to satisfy all of you. Okay, thank you again, and see you next 1st of October here. Bye.
Bye. Bye. Thank you. Bye.
Bye. Grazie.